James Webb Space Telescope has captured the antics of a pair of actively forming young stars, known as Herbig-Haro 4647s, in a high-resolution image in near-infrared light. This is the most detailed portrait of these stars, which reside only 1470 light-years away in the constellation Vela, to date. To find the pair of young stars, trace the bright pink and red diffraction spikes in the image until you hit the center. The stars are within the orange-white splotch. They are buried deeply in a disk of gas and dust that feeds their growth as they continue to gain mass. The disk is not visible, but its shadow can be seen in the two dark, conical regions surrounding the central stars. The pair of actively forming stars has sent out jets in two directions for thousands of years. Although Herbig-Haro 4647 has been studied by many telescopes, both on the ground and in space, since the 1950s, Webb is the first to capture them at high resolution in near-infrared light. With Webb, we can now understand more of the star's activity, past and present, and peer through the dusty blue nebula, which appears black in visible light images, that surrounds them. Over time, researchers will be able to glean new details about how stars form. The most striking details are the two-sided lobes that fan out from the actively forming central stars, represented in fiery orange. Much of this material was shot out from those stars as they repeatedly ingest and eject the gas and dust that immediately surround them over thousands of years. When material from more recent ejections runs into older material, it changes the shape of these lobes. This activity is like a large fountain being turned on and off in rapid, but random succession, leading to billowing patterns in the pool below it. Some jets send out more material and others launch at faster speeds. Why? It's likely related to how much material fell onto the stars at a particular point in time. The star's more recent ejections appear in a thread-like blue. They run just below the red diagonal diffraction spike at 2 o'clock. Along the right side, these ejections make clearer wavy patterns. They are disconnected at points, and end in a remarkable uneven light purple circle in the thickest orange area. Lighter blue, curly lines also emerge on the left, near the central stars, but are sometimes overshadowed by the bright red diffraction spike. All of these jets are crucial to the star formation process itself. Ejections regulate how much mass the stars ultimately gather. Now, turn your eye to the second most prominent feature, the effervescent blue cloud. This is a region of dense dust and gas, known both as a nebula and more formally as a Bok globule. When viewed in mainly visible light, it appears almost completely black, only a few background stars peek through. In Webb's crisp near-infrared image, we can see into and through the gauzy layers of this cloud, bringing a lot more of Herbig-Haro 4647 into focus, while also revealing a wide range of stars and galaxies that lie well beyond it. The nebula's edges appear in a soft orange outline, like a backward L along the right and bottom of the image. This nebula is significant. Its presence influences the shapes of the jets shot out by the central stars. As ejected material rams into the nebula on the lower left, there is more opportunity for the jets to interact with molecules within the nebula, causing them both to light up. There are two other areas to look at to compare the asymmetry of the two lobes. Glance toward the upper right to pick out a blobby, almost sponge-shaped ejecta that appears separate from the larger lobe. Only a few threads of the semi-transparent wisps of material point toward the larger lobe. Almost transparent, tentacle-like shapes also appear to be drifting behind it, like streamers in a cosmic wind. In contrast, at lower left, look beyond the hefty lobe to find an arc. Both are made up of material that was pushed the farthest and possibly by earlier ejections. The arcs appear to point in different directions, and may have originated from different outflows. Take another long look at this image. Although it appears Webb has snapped Herbig-Haro 4647's edge on, one side is angled slightly towards Earth. Counterintuitively, it's the smaller right half. Though the left side is larger and brighter, it is pointing away from us. Over millions of years, the stars in Herbig-Haro 46 of 47 will form fully, clearing the scene of these fantastic, multi-hued ejections and allowing the binary stars to take center stage against a galaxy-filled background. Webb can reveal so much detail in Herbig-Haro 4647 for two reasons. The object is relatively close to Earth, and Webb's image is made up of several exposures, which adds to its depth.